LiquiTech Environmental, bringing innovative technology backed by third-party validation and ongoing system performance documentation, providing a safer environment of care.
This video will demonstrate and explain the unique features of closed-loop proportional control available in the Generation 3 LiquiTech copper-silver ionization systems. It will show how the system can automatically adjust for variations in water conductivity and illustrate the remote supervisory control and alarm call-out capabilities. The latest generation LiquiTech ionization systems are composed of four main components, those being the controller, integrated ultrasonic flow meter, the REMS supervisory control module, and an ionization chamber. The flow meter, using ultrasonic technology, measures the amount of water to be treated and continuously sends a flow signal to the controller. The controller uses this flow signal and an algorithm programmed into the unit to determine the appropriate amperage setting needed to achieve the desired amount of copper and silver ions to be introduced into the water. The system reacts instantaneously to variations in water demand by automatically sending a signal to the controller, directing it to increase or decrease the generation of copper-silver ions released from the ionization chamber in order to maintain the optimum targeted levels. Let's demonstrate this concept. In looking at the display on the controller, you will see that at zero flow, there is no current being passed across the electrodes. As water flow increases, the amperage increases proportionally to this rise in water demand. If we reduce water flow, you will now see the amperage drop, again proportional to the decrease in water usage. You can now see how this control strategy, unique to LiquiTech systems, serves to keep much tighter control of copper and silver levels. The controller display shows voltage along with amperage and water flow. Whereas the amperage is a measure of the amount of current being sent to the electrodes, voltage can be defined as the amount of driving force required to maintain the desired current or amperage. The LiquiTech system automatically varies the voltage to compensate for changes in water conductivity and maintain the desired amperage. This important feature automatically compensates for variations in water quality. Let's now demonstrate this capability. Under steady conditions illustrated here, the amperage and voltage are constant. The system is very sensitive and able to compensate for even the slightest variation in water quality. Here we will add salt to the water to raise the water's conductivity. As this happens, you will note that the volt reading on the controller decreases. This is because with higher water conductivity, it is easier to pass current through the water and we do not need as much voltage or driving force. The controller senses a change in conductivity and automatically adjusts voltage to maintain the desired amperage output. Let's now look at the remote monitoring and control features of the equipment. Through an internet connection to the supervisory control module, we can remotely monitor the system to see all of the data on the virtual control interface. Here's an example of one of the screens that can be accessed remotely via computer. As you can see, we have a view into all the operating data as well as the alarm status. Another key benefit of the remote monitoring system is the alarm feature, which sends out notifications via email and cell phone. This enables us to immediately respond to any interruptions in system operations. As the system encounters an alarm, a notification is sent to LiquiTech. The application engineer connects remotely to the system to view the alarm status. Appropriate action is then taken to clear the alarm and restore normal system operation. In this video, we have demonstrated the key features that are unique to LiquiTech systems. The ability to compensate for both water consumption and changing water makeup variations. Remote access and control capabilities of operating parameters. 24/7 alarm response capabilities. validation, and documentation.